So we were learning about dimensions, and dimensions of length L, mass m, time t, current A, thermodynamic temperature K, intensity CD, candela, and amount of substance mole. Again, these are in square brackets. That shows that these are dimensions. So why do we use these dimensions? These dimensions hold a very significant work in physics, so that we will learn. And with this, when we see a square brackets, so we can say that this is the dimension of the quantity. This is the dimension of the quantity. Why this is helpful? Suppose anything has a dimension of just L. So we know without seeing its unit, whether these are centimeter, in meter, or in any other quantity, we must know that this is something has to do with length. Something has to do with length. Again, many complex quantity can be represented by these simplified dimensions. So we just use these simplified dimensions and we can tell this quantity is made of, let us say, is made of length and mass. This quantity is made of length and mass, and square of this, or third power of mass, or first power of length. So in this way we can analyze the quantities, that this quantity depends on first power of length and third power of mass. So this is the purpose of these dimensional analysis. So let us learn this by an example. So in mechanics, all the physical quantities can be written in terms of length, mass, and temperature. This time, length, mass, and time. So let us see the example. So length is L. So again, the length, breadth, and height, all three are lengths. This is our notation, but all three are lengths. So dimension, what is the dimensions of volume? So dimension of volume is L cross L cross L, that means L cube, and in the bracket we get L cube. So whenever we see this L cube number, then we know for sure that it has something to do with length, and length. So as the volume is independent of mass and time, it is possess zero dimensions of that. So in the volume we don't have mass, so mass to the power 0, and this time to the power 0. So when a quantity, physical quantity, does not depend on any dimension, so we put 0 power of that. So we can represent in general volume as mass to the power 0, length to the power 3, or this time to the power 0. This is in general case, or we can simply represent it as L cube. Similarly, force as a product of mass and acceleration. So how will we write force? So let us understand how do we write force. So we know force is equal to mass into acceleration. So this is force. Mass is m, and acceleration is, we know acceleration is velocity upon time. Velocity is again distance traveled. Let us say distance traveled. So this is the formula, d2x upon dt square. So this is distance traveled upon time square. So what are units of acceleration? Meter per second square. Meter is unit of length. So this is length and this is time. So t square. So force is mass into length upon t square. So what are the dimension? Mass is m into L. This is length is L divided by t square. So these are the dimensions of force. Now let us write in a proper way. So in proper way we can write it as m, this L, both have one power. This t square, when it goes up, it becomes minus power, ml t minus 2. So these are dimensions of force, ml t minus 2. So in this way we write dimensions of different physical quantities, and they give us a hint that on what quantities and what power of those quantities these physical quantities depend. So force is proportional to mass. proportional to length but inversely proportional to square of time. So this we get with this dimensional analysis. So here what we get, if we have written it like this, so volume is mass to the power 0, L to the power 3, T to the power 0. So with this quantity we can say that volume of any quantity does not depend on mass, does not depend on time, it depends only on the cube of length, cubic power of the length. So this is the benefit of using this dimensional analysis. Remember, in this representation, that means dimensional representation, we don't consider the magnitudes of the quantity. So a change in velocity, initial velocity, average velocity, final velocity, speed, all are equivalent because all have units meter per second. Hence dimensions are length upon time. That's why we represent is as LT minus 1. So in this representation, any type of velocity, whether this is difference of two velocity, final and initial velocity, difference of that, change in velocity, so they are all are same. Now dimensional formulae and dimensional equations. The expression which shows how and which of the base quantities represent dimensions of a physical quantity is called the dimensional formula of the physical quantity. So dimensional formula of volume is m0 L cube T to the power 0. So this is dimensional formula. Also dimensional formula of velocity is LT minus 1. So this is dimensional formula of velocity. m0 L T minus 1, this is for volume. This is the dimensional formula for acceleration, m0 L T minus 2, m L minus 3 T to the power 0. So here this is mass to the power 1 divided by L cube and T is 0, that means this is the formula for density. So these are dimensional formulae. Next thing after dimensional formulae, the next thing is dimensional equations. So an equation obtained by equating a physical quantity with its dimensional formula. So these are dimensional formulae of any physical quantity. So when we put that physical quantity equal to this dimensional formula, so we call that dimensional equations. So here are the dimensional equation for volume, speed, force, mass density. So very similar to normal formula. So how can we calculate speed? Speed is simply distance, let us write by s divided by time. So this is the formula for velocity, or this is the equation for velocity. So this is our formula. When we write this formula in form of dimension, so how did we write in dimensions? L T minus 1. So this is dimensional formula, and this is equation for velocity or speed. This is equation for speed. So what is the equation for dimensional equation for speed? This is simply V in this bracket and this LT minus 1. So this is dimensional equation. So here some of the dimensional equations are shown. For volume, m0 L cube T to power 0. So see, here we have equate this physical quantity with its dimensional formula. So equation of any physical quantity with its dimensional formula is called dimensional equation. This is speed. Speed is m0 Lt minus 1. Force is mlt minus 2. Density is mass divided by L cube, ml minus 3 T to the power 0. In this way we write the dimensional equations. So what is the benefit of dimensional equations? So the dimensional equation can be obtained from the equation representing the relation between physical quantities. So we have seen this thing for speed, this is s by t. Similarly, we can obtain these dimensional equation for different type of quantities like f is equal to m into a. So we can obtain these equations, dimensional equations. the dimensional formula of large number of wide variety of physical quantity. So we have seen there are very large number of physical quantities, very large number of quantities derived from the equation representing the relationship among other physical quantities and expressed in terms of base quantities. So what is the use? The use is that though there are a very large number of quantities, very large number of physical quantities, but they can simply express by these 7 basic dimensional quantities. So that is the power of this dimensional analysis or this writing in dimensional equation. So a large number of physical quantities, as we have learned that very large or complex quantities can be written or their units can be written in basic units. What were the basic units? Meter, kilogram, second, etc. So we have learned how to write very complex unit in these simple units. Similarly, this dimensional analysis or this dimension equation give us a way how to express very difficult quantities with 7 basic fundamental quantities.